In this video I will show how to control stepper motors with the Raspberry Pi, including schematic, an example of source code and a physical system demonstration. The gpiozero library for Raspberry Pi unfortunately doesn't include a stepper class, so I created my own class and I will give you a file, a Python file, so that you can use it in your projects. In this video we will use 28 BYG stepper motor. It's quite small, and to control the motor we will use ULN 2003 integrated circuit. It's already pre-installed in a small board. It is possible to use L293D integrated circuit that we have used to control regular motors, but it is not convenient, and since I already have a pre-built board with ULN 2003, I will use it. Now let's look at the complete circuit drawing that includes Raspberry Pi, our stepper motor, and ULN 2003 integrated circuit that is installed on a small board. The wiring is quite simple, but for my stepper motor I had to switch two wires. Let me explain. The green wire goes from Raspberry Pi GPIO 5 to input 1. The blue wire goes from Raspberry Pi GPIO 19 to input 4. There is nothing unusual about these two wires, but the purple wire and the orange wire have different assigned pins in my source code. You will see it later when I will show you the source code. So the purple wire goes from GPIO 6 to input 3, but in my source code it assigned to input 2. And the orange wire goes from GPIO 13 to input 2, but in my source code it assigned to input 3. If you notice that your stepper motor does something wrong, it doesn't work, try to switch these wires, or maybe try to switch other wires. This is a Python program, an example of Python code that controls a stepper motor on Raspberry Pi. It imports the stepper class from stepper module that I created, and to initialize my step motor I call this stepper class, and I provide the number of steps, which in this case is 2048, and pins of GPIO. I set the speed of step motor as 10 RPM, rotations per minute, and in the main loop I call this step method in which I provide the number of steps to go. In this case it's 1024 steps, which is half of the full rotation. So the motor in this program rotates 2 times half of the full rotation, so in one direction. Then it rotates backwards, the opposite direction, also 2 halves of the full rotation. In the end of the program I call this stop method to turn off all pins. There is a stepper module that contains the stepper class with all methods that I use in this step program. All these files are available in GitHub repository, and the link to that repository is in the description of the video. Alright, it is time to upload our program to Raspberry Pi. I need to create two files, one for our stepper class module another for the program that controls our stepper motor. You can see that in the folder we have two files, stepper.py and step.py, and I'm gonna run python step.py. The program prints that it rotates motors as we expect. To exit the program, press Ctrl+C. Now I will go and show you how this system works in real life. This is how our step motor performs in the real world. To achieve smooth and precise rotation, as you see in this video, try to use small RPM values, like no more than 10 RPM. That's all for this video. Thank you for watching.